Hello students. Uh, Today I am going to discuss with trigonometric identities, and this is the very first chapter of your class 10 identities part. Okay. Now this trigonometric identities is related with your right angle triangle. You have a right angle triangle in which one of the angle is 90 degree, and the side opposite to this 90 degree is known as hypotenuse. This one is the perpendicular, and this is known as the base. Now assuming this angle, suppose if you consider the triangle to be as A, B and C, making angle B as 90 degree. So this forms your right angle triangle. Now for trigonometric identities, we are supposed to know the trigonometric basic ratios what we have. Okay. So the ratio starts with the first one as, let's do the basic trigonometric ratios. These are also known as T ratios. Okay. The first one as sine. Now if I assume this A part to be as theta, angle A is theta. So if you're calculating sine theta, then it should be perpendicular divided by hypotenuse. Okay. So sine theta is perpendicular by hypotenuse. Now let us work out with this particular ratio with one example. Suppose if I consider in this triangle, this is a triangle ABC. So in triangle ABC, I consider side BC, that is the perpendicular, to be as 4 centimeter. Then your base to be as 3 centimeter. Then according to Pythagoras theorem, if AC is not provided to you also, you can calculate using your Pythagoras theorem, which is AC square, and that gives you BC square plus AB square. So it comes to how much? 4 square plus 3 square, that gives me 25. So the value of your hypo is equal to 5 unit, whatever is it, it's centimeter, so it should be centimeter. Now if I am putting the value of sine theta, then what should it be? Perpendicular by hypo. What is the value of perpendicular? The perpendicular value I have considered as BC, which is 4 centimeter. So this should be 4 centimeter divided by hypo, which is 5 centimeter. So now sine theta will be equal to 4 by 5. No ratio, no units over here. Alright, because this is a ratio. Likewise, when you are calculating cos theta, your cos theta should be equal to base divided by hypo. So in this, the base is how much? I have assumed the base to be as 3 centimeter. So this will be 3 divided by 5. So cos theta is 3 divided by 5. Now, then we have tan theta. So what is tan theta? Tan theta is equal to perpendicular divided by your base. So how much is the perpendicular? It's perpendicular is BC. How much is BC? Which is 4 centimeter divided by base 3 centimeter. So the value of tan theta is 4 by 3. So we have seen in a right angle triangle, if any one of the, theta, if A is theta, then its opposite side is considered to be its perpendicular. Likewise, if suppose you consider this C to be as theta, then this should be its opposite side. Okay, so in that case, this will become the perpendicular. So depending on the value of theta, you're going to decide which one is its perpendicular side. Okay, so this is your perpendicular, this is your base, this is your hypo. With the help of Pythagoras theorem, you're going to calculate the value of hypo. If hypo is provided to you, in case if perpendicular is not given, then with the help of hypo and base, you're going to calculate the value of perpendicular. If base is not given, then with the help of hypo and perpendicular, you can calculate the value of its base. Okay, so these are the basic things. Now, after that, we have calculated the value of sine theta, cos theta and tan theta. Okay, now then we have the inverse of these ratios. Alright, so what we do, we are going to proceed further with this. In this case, we have this number 4, which is the inverse of sine theta. So sine theta, what it is called? It is cosec theta. And what is cosec theta? Cosec theta is the inverse of sine theta. So in that case, it should be hypo by perpendicular. Alright, hypo by perpendicular, simply I can write it as h by p. So if the value of sine theta is 4 by 5, then cosec theta will become 5 by 4. Right? Likewise, let's proceed. Number 5. That is cos theta, inverse of cos theta. Okay. Inverse of cos theta, let's work out here. What is it? Sec theta. What is sec theta? You can write inverse of cos theta. So if it is inverse of cos theta, can I write hypo by base? So in this case, if cos theta is 3 by 5, then what is sec theta? Sec theta will be 5 by 3. Alright. Now students, we can even write, one more thing. What is it? Cosec theta, if it is written as hypo by perpendicular, we can also consider it to be as 1 by sine theta. Likewise, the sec theta can also be considered as 1 by cos theta. Alright, the sec theta is 1 by cos theta, cosec theta is 1 by sine theta, and the last one is your cot theta. What is cot theta? Cot theta will be base by perpendicular. Okay. Base by perpendicular is considered to be as cot theta, and that can also be written as 1 by tan theta. So you see, tan theta is 4 by 3. 1 by tan theta is 3 by 4. So let us quickly recapitulate what we have done. Okay, we have started with the trigonometric identities, in which we are considering your right angle triangle, considering one of the angle to be as the unknown angle. Okay, and that I consider it to be as theta. The side opposite to it will be its perpendicular. Okay, and the adjacent side is known as its base. Correct? Then we have always the side which is opposite to right angle is considered to be as the hypotenuse. Now we are defining the trigonometric ratios, and quickly let's look into the trigonometric ratios. The first one is sine theta, which is considered to be perpendicular by hypo, cos theta, which is base by hypo, tan theta, which is perpendicular by base. Okay, these are the basic ratios, and then we consider its inverse ratio, which is cosec theta, sec theta and cot theta. Okay, they are just the inverse of cosec is inverse of sine, sec is inverse of cos, and cot is inverse of tan. Alright, I hope it's clear till here. Okay.